Lesson 5 has 3 parts. The first part is on types of numbers, and make sure you've looked over your rules and definitions for this lesson before you start, though, and make sure you're taking notes, that you have the word Lesson 5 up at the top, and that you have a subtitle, Part A, Types of Numbers, and that you're ready to take notes here. And also, make sure you have the right attitude. You have a thankful attitude, thankful that your parents have allowed you to use this course and to do your math and to do it to the best of your ability, and just thankful to God that you're able to learn about Him by doing mathematics as well. That's the most important thing. So be grateful to Him, thankful to Him, have the right attitude that you can do this, you can figure it out, be patient, persevere, all those good kinds of things. So anyways, in lesson 3, we define number. We define that as an idea representing a quantity. And God designed us to enjoy organizing things, and that helps us explain them better. Numbers are no different. So here in Part A, we're going to learn about different types of numbers, and all of them are defined in the Lesson 5 definitions, all the things we're going to cover here. So memorizing those, that would be the very best thing to do, because then they're just right in your mind. You don't have to go look them up again. But if you need to, refer back to those as you need to. You don't need to write them all down, just know where to find them. So refer to those definitions as you need to, and you'll get more familiar with the different number types by answering questions that help you compare and contrast them, like this example 5.1. So let's look at that. Which number type is also known as a counting number? Maybe you remember that. If you remember that, go ahead and answer, and then just fast forward to the next example. But if you don't know that, if you're clueless about that, you might want to look up your number types. But I'll put them up here. I'll put our definitions for lesson 5 up here on the screen. And looking through those, we see that natural numbers are also referred to as counting numbers, and those are like finger counting, right? When you start counting with your fingers, you don't start with 0, because you don't like make a circle with your fingers or something. You start with your thumb or your index finger, whatever you want to do, and 1, 2, 3, 4, 5, and go like that. And so those are a way to remember what counting or natural numbers are. And so that would be choice A. Look at example 2. Which set of numbers begins with 0? So we have same 4 choices again here. So it can't be A, it can't be natural numbers. And if you look through your definitions, whole numbers, counting numbers, and the number 0. So choice B is the correct choice there. Example 3. Which number type includes fractions and decimals? So again, looking through your definitions, if you don't know what that is, that would be the real numbers here, right? And we have an example there, anything used to describe a positive or a negative number. And we have definitions for both of those down here if you're not sure what the difference is. And that includes all integers, all decimal numbers, and fractions. And so we have some examples there, like 2/3, 1.2234, -17. All of those things are real numbers, so that's choice D. And that's an important distinction of real numbers and the other groups, because anytime you see a decimal number or a fraction, you know it cannot be a natural number, a whole number, or what we describe as an integer. So memorizing those different number types, obviously that's going to help you with distinguishing them. So try to do that, try to get those memorized, and your math will go faster for you as well. Let's move on to part B and number lines. And number lines, they're a useful tool for understanding signed numbers, and meaning they have a plus or a minus sign in front of them, positive or negative. A common example of a negative number is temperature. Maybe you live somewhere where the temperature gets down to negative 10 degrees Fahrenheit or -5 degrees Celsius. Some kind of negative number. That a lot of times we don't put a plus sign in front of a number for a positive number. It's just understood it's positive if it doesn't have a minus in front of it. But anyways, a number line, like you see here, it's just a horizontal line with or without arrowheads at the ends, like that one has those arrowheads there and there, but it may not have that. Divided into equal sections. like you see on a ruler, or like you see here, like the difference between those two. It's the same as between these two. It's equally spaced. Sometimes we call those tick marks. We'd say those tick marks are equally spaced, like you see on a ruler. And so a number line is usually drawn with a 0 at the center right there. Positive values to the right, negative values to the left. The length of a number line is only limited by the size of your paper or your computer screen in this case. And one way to think about negative numbers in particular is that they are the opposite of a positive number. So, I mean, think about it starting at 0 and we go to 2, we go 1, 2 spaces over, right? Now, negative 2, it's the opposite of that. We go in the opposite direction, but we go 1, 2 spaces or 2 tick marks over, right? So it's like the same distance away from 0. It's just the opposite direction. So minus 2, we could think of that as the opposite of 2. They have that same distance, just the opposite direction for the negative. So that phrase, the opposite of, is helpful for thinking of negative numbers. And we can use a number line to compare number sizes. A simple thing to remember is that numbers to the right are greater than numbers to the left. Numbers to the right are greater than or bigger than numbers to the left. So for example, numbers to the right of 0 are greater than numbers to the left of 0. We can use a comparison symbol. Those were in your rules. Simplify comparing numbers. So for example, if we wanted to compare 4, put a dot right there for 4, and 7. Remember, numbers to the right are greater than numbers to the left. So one way we might write that is 4 is less than 7. We could also write 7 is greater than 4. We could write it like that as well. Let's go ahead and do some practice now on using a number line and solving some problems. So example 4 here says organize the following numbers from least to greatest by graphing them on a number line. So I'm going to quickly put a number line up there on the screen. Take your time. You should do one as well on your paper. Now, when you do one on your paper, this is not art class. You can use a straight edge, a ruler, something to help you make it straight, or you can just do it as straight as you can. Go try to find the middle of your number line, put a tick mark there, 0. Try to make these marks evenly spaced. Of course, they don't have to be perfect. Okay, you're not going to get the problem wrong because your tick marks aren't evenly spaced. You'll get it wrong because you didn't put something in the right order. Number them 1, 2, 3, 4, 5, and so on. Number your number line, negative direction as well. And you can, if your numbers feel like you're too close together, you can skip count too, -4. So we know like this one right here is a -3, but we just didn't put that just because we're going to cram things together too close or whatever. So you can skip count like that as well if you want to, just understanding that there's a -7 between -6 and -8 that you didn't write down. So now organizing those from least to greatest, and starting with the 6, put a 6 right here, and then the -2, that's right here. The 1, that's right here, and the 0 is right there. Okay, so now what we want to do for the answer to this is just look at the order there from left to right. -2 is least, and then you just do comma, 0, comma, 1, comma, 6. Okay, so we marked them and labeled them first, and then we wrote them down. And remember, on our answer, we like to box our answer just to show where the answer is. So that's what we mean when you see another problem like this where it says organize the following numbers from least to greatest. That's what you're supposed to do. Use your number line to help you. As you get better at this, you won't need a number line anymore. You can just do it in your head. Do mental math, it's called. Example 5. Rewrite the expression below by replacing the box with the correct comparison symbol. So we mean should we put a greater than symbol there, a less than symbol, or an equals symbol? Those are your symbols from the Lesson 5 rules. So a good way to start, let's make a number line. We see two negative numbers, so put a 0 in the middle here, put a couple of tick marks to the right, but we're really not concerned with positive since both of our numbers we're comparing are negative. So I'll put a -1, 2, 3, 4, 5. Let's label them. -5, -4, -3, -2, -1, and then we have 0 there. So comparing these, here's -5, here's -1. To the right is always greater. To the right is always greater. And so we have a -5. We want to replace that box right here. We want to change that with the right comparison symbol. So -5 is to the left, so -5 is less than -1, right? Because -1 is greater than -5. So, we can read these right to left, starting with -1. Notice, that mouth, it kind of looks like a mouth, right? So this side is the open mouth. This side's the open mouth, but that always points towards the larger number. So we see that there. But normally we read these left to right. So we say -5 is less than -1. Next, example 6. Use a number line to add 1 plus 3. Now you probably know that's 4 already. So the point here is not, why do I have to do this? I know what 1 plus 3 equals. Come on. Use a number line to do this. So get the feel for using one, because we're going to add some negative numbers, which you may not be quite as used to doing, right? So we have two positive numbers here. We'll just go 1, 2, 3, 4, 5. You make your number line. Look at how imperfect mine is. You don't have to make a perfect one. Just try to do as best as you can, okay? It's not a big deal. Okay, so now what we want to do is, if we're adding 1 plus 3, we want to start at 0 and go to the right 1. And then we add 3 more to that. So 1, 2, 3. And where are we at? We're at 4. Okay, but you already knew that. But that's how we use a number line to add things. Start at 0. Make a note of that if you need to. You always start at 0. And then that first number, if it was a -1, it would have gone to the left. It's a +1, so we go to the right. And then we go to the right 3 more because it's a +3. Okay? So the answer is 4. Number 7, use a number line to subtract. Okay, you look at that 3 minus 1, you already know that's 2. Why are you using a number line? Well, the point is to use a number line, not to see if you know what 3 minus 1 is. So again, where do we start? Start at 0. If you've forgotten already where you're supposed to start, write that down. Write that phrase down. Start at 0. Write that down. We want to go to the right 1, 2, 3. Okay, so now we're at 3. Let's label it 1, 2, 3, 4, 5. Okay, now we've gone to the right 3 minus 1. That means we have to go back to the left. So let me change colors here. I'm going to go to the left 1. I'm at 2. Right? I went back to the left because it's a -1. We're at 2. 3 minus 1 is 2. One more here, and then we'll move to part C. Use a number line to subtract 1 minus 3. Okay, now that's a little bit different. We have a smaller number minus a bigger number. So make our number line. Where do we start? Think about where you're going to start. What did we say? Starting at 0 all the time. So let's do some this way. Let's do a few tick marks this way as well. -1, -2, -3. Okay. Start at 0 to the right 1 because it's a plus 1. It's understood if there's no plus or minus sign out front, it's understood that that's a positive 1. And so we go to the right 1. Now we need to go to the left because it's a minus 3. We're subtracting 1, 2, 3. Where do we end up at? We end up at minus 2. That's our answer. Our answer is minus 2. Now, in our rules, we had integers, right? Positive and negative numbers. Don't be surprised by negative numbers. They do exist, just like we were talking about temperature a while ago. Recall from your definitions, too, that integers and real numbers, those include negative numbers. Real numbers are numbers that can be graphed on a number line. There are also numbers called imaginary numbers. They can't be graphed on a number line. That sounds kind of weird, but you're going to learn a little bit about those in lesson 30, so not for a while. Moving on to part C and sequences. In Shormann math, one way we define mathematics is a tool for identifying patterns, right? That's part of our definition, tool for identifying patterns and shape. One way you may have used the word pattern in the past is to describe a repeating design, like a floral pattern on a fabric, for example. Sequences are simply patterns involving numbers. So here in part C, you'll get a little taste of algebra as well, just a very small taste, as you learn to use variables to identify patterns in a sequence of numbers. So take a look at example 9 here. Find the missing terms. So we see some missing terms here, A and B. And that's a sequence that we have there. Notice how K depends on the value of N. So we have this position, and we're just giving it a name. We're calling it position N and term K. And we use two different letters there so that we don't confuse the two. Okay? K depends on N. So when the position N is 1, then the term K is 2. Okay? Skip 2, but look at 3. When the position is 3, the term is 6. When the position is 4, the term is 8. When the position is 5, the term is 10. Do you see a pattern there? 1 goes with 2, 3 with 6, 4 with 8, 5 with 10. Can you figure out from that, well, 2 must go with what? And 6 must go with what? So think about that. 6, 8, 10, 12, right? B must be 12. If we keep that pattern going from the beginning, 2, 4, 6, 8, 10, 12. A must be 4. When the position is 2, the term is 4. Okay? So then it says what formula? We've partially answered this question. It's asking now what formula describes this pattern. So there's two questions here we need to answer. Now, when N equals 1, K equals 2 times 1 is 2. Do you see that? We can use the value of the position, which is 1, times it by 2, double it. That gets us the term. When N equals 2, K is equal to the position times 2, right? We double it, 4. When N equals 3, K equals 2 times 3, the position, 6. Every time it's 2 times the position, that's the term, right? Do you see that? So the formula K is equal to 2n. Whatever the position n is, we double it. We times it by 2. That gives us K. That means also 2n means 2 times n. We didn't do 2 times n. We didn't say 2 times n. We didn't say 2 parentheses n. We just said 2n. You might want to make a note of that when you see something like that, a number and a variable in math, in your math class. That means 2 times n. Okay? So we save a step there, right? We don't have to write those kinds of things down because it's understood that's multiplication. that's going on there. K equals 2n. That's your pattern. Let's do one more. Find the missing terms in the sequences shown. It's the same questions, but just a different set of numbers here. Maybe you can figure it out. You can pause the lesson if you want to and try to figure out what A and B are and then what the formula is. You can do that if you want to. So let's just look at it. 1 goes with 1 right here. 2 goes with 4. 3 goes with 9. 4 with 16. Do you see what's happening there? Can you recognize that? It's perfect squares, right? Those are perfect squares. So 2 squared is 4, or 2 times 2 is 4. 3 times itself, 3 times 3 is 9. 4 times 4 is 6, and so on. Perfect square is one of your definitions. Remember, you're supposed to look at your definitions before you start the lesson, so that phrase, perfect square, should be familiar to you because you studied your definitions before you started the lecture. That's a result of multiplying a counting number by itself. That's what a perfect square is. So hopefully from that you can figure out, well, if the position is 5, then the term is 5 times 5, so A is 5 times 5, 25. And then B would be 6 times 6, 36. Okay? So what's the pattern there? What formula describes the pattern? So like in problem 9, we had a formula, K equals 2n. That's what a formula is. It's like an equation kind of thing. Here, when n equals 1, K is 1 times 1, right? When n equals 2, K is 2 times 2, right? K is 4. When n equals 3, K is 3 times 3. So it's n times n, right? That's what K is. So K is position times position, n times n. So there's our formula. There's other ways we could have written that, right? Because there's other ways to do right multiplication. We could have said n times symbol n like that. We could have said n parentheses n. Something you'll learn later about exponents, maybe you already know. Don't worry about it if you don't. You could say n squared as well. That's another way. Okay, well that's all for lesson 5.